All right, we are now recording the whole workshop right now. How? So let's keep going. And like you can see the slides right now, right? 你有看到简报齁？有。OK， 那我就继续了。Right, so yeah, GPlates is a Python-based software, and there's another phase of kind of GPlates like the PyGPlates. It's like GPlates is the interface, while PyGPlates like a Python library that you can use to directly call out those functions in GPlates and more to do play reconstruction stuff. 就是 GPlates 呢，它是一个 Python 所 driven 的软体。那除了 GPlates 之外，就是它 GPlates 是一个有界面的软体嘛。那除此之外呢，你也可以使用另外一个叫做 PyGPlates 的 Python library， 就是它基本上就是你可以直接用 Python coding 的方式去使用任何的 play construction 的功能。甚至它其实比 GPlates 还要更没有限制啦，因为 GPlates 毕竟是一个界面，就是你就只能做那个界面上可以做的事情这样而已。Yeah, so I was talking about like the GPlates is an interface which is easy to interact with, like straightforward. But when you use PyGPlates, like you can actually do more because while GPlates is an interface that kind of restricts the function that you can use, while PyGPlates, like you can do whatever you want. And so why are we using PyGPlates? The way I see it's like for us geologists, like we are all looking into those topics, like geological topics, in a way that we concerned about the locality and the time, right? 就我们是身为我们这些地质学家，我们在讨论任何事情的时候，其实时间跟空间都是我们最关注的嘛。And so that's why we all kind of need to understand how GIS system works, like the geographic information system, right? To understand where and when our sample was collected, and also like what the geological event was happening at what location and time. And on the other hand, like that's also the reason why most of us also kind of have the experience for some GIS software like QGIS or ArcGIS, right? 就是因为我们关注的是时间跟空间的问题嘛，所以特别是空间上，所以我们多多少少都会需要用到一些地理资讯处理的那个知识，甚至是软体，像是 ArcGIS 或者是 QGIS. But for those GIS software, they are mainly good about showing the locality, right? They shows how the distribution of those things in space, but not time, right? Like when you use ArcGIS or QGIS, it's mostly showing that where the samples you collected are, and not like time in terms of times. Like it doesn't really have that. And I would say that's the benefit for using GPlates, because in my opinion, it's kind of like the kind of a QGIS, but with the ability to go back in time. 就是因为我们在使用那些 GIS 软体，就是 ArcGIS 或者是 QGIS 的时候啊，它比较擅长的就是空间上的资讯处理嘛，但是时间上就没有办法了，就是所以我会觉得 GPlates 呢就是 QGIS， 但是再加上这个时间上的功能这样子。So what really geologists care about time is that because we got plate tectonics that move things around, like the continents are moving everywhere and the ocean plates are also moving everywhere and subducting. And so if we are talking about something like some geological event back in time, say like 100 million years ago or 1 billion years ago, like and we want to use this rock sample from a specific locality to talk about that event happens in like 100 million years ago. We to be able to describe that location back in time, we also have to talk about how plate tectonics driven those blocks, like where the blocks were, right? So you can tell like literally the true locality of that sample, something like that. 就是说，因为我们特别是我们在讨论那些几百万年前的事情的地质学家，就是我可能在一个地方收集了一个岩石，然后我想要透过这个岩石来去了解一些地质的事件，而且是可能是100万年前的事件。那这个时候呢，我就要考虑的是，如果我想要知道它真正的位置，在100万年前的位置，那我不能就只是说，哦，我在比方说那个台湾的海岸山脉拿到这颗岩石，因为在100万年前，可能那时候台湾还不在了。如果举另外一个例子好了，假设在北美的那个内华达州好了，我拿到一块石头，然后但是在100万年前呢，内华达这个地方它不在它现在的位置，所以我们如果真的要更精确的去描述它的位置的话，我们就需要使用 GPlates 来，或者是说学就是任何一个那个板块重建的模型来多少知道说它在100万年前在哪里。And like that's kind of the way people one way people that use plate reconstruction model. And the other things like you can also talk about other process that was driven by plate tectonics, like, and that's for like, and that's why people are also applying reconstruction models on geodynamic and paleogeography or even paleobiography or even like talk about paleoclimates, right? 就是也因为就是除了这些样本的古地理位置之外呢，因为这些板块运动呢，它也同时驱动了其他的一些事情嘛，比方说地寒的那个动力学啊，或者是那个古气候啊、古海洋的演变啊，这些通通都跟板块运动有关，因为板块运动算是地球历史上至少一半的历史上驱动很多地质长周期的地质作用一个很大的驱动力这样子。Yeah, I was talking about like since like these are important because plate tectonics is arguably one of the major driven forces for lots of long-term geological process, right? Like paleoclimates or mantle geodynamics. And that's why people or say like that's how people are using it. And as why we use GPlates, like so I recall that GPlates is not the only choice for you to do plate reconstruction, but some of the reason for using GPlate is first of all it like they make it into a way that easy to do plate tectonics and also geodynamics modeling. And the other thing is like it makes visualization quite easy and good. Like it can show the surface and deep earth like geological distribution in 4Ds easily. And the other things like because it's so good at visualization, it's not only good in research, like because when you're talking about something happens back in time with like everything is not in its present day location, it would be good to have this kind of paleo geography map to show your ideas, right? Like it's really convenient for ideas communicating, and also it's easy for teaching as well. Like you can show how plate reconstruction works visually, and like literally, I know the GPlates community, well, part of the GPlates community are actually high school teachers. Like they're using GPlates to teach plate tectonics, like show the students how the plates were moving around, right? 就是也因为这些优势啊，所以大家使用 GPlate 的方式就是哇，这样我在要翻什么？好，就是再来是为什么要使用 GPlates？因为其实还有其他的一些那个选择啦，就是如果你要做板块重建的话，那我可以想到一些就是 GPlates 的优势是说，首先它跟很多的 geodynamic modeling 的那个模组有很好的那个连接啦，所以很多人使用的方式是，我先用 GPlates 来做出一个板块模型，然后把这个板块模型当做是 input 来去做 mental modeling， 去做那个地函的那个随着时间的模拟这样子。那此外就是GPlates 呢，它在visualization 我视觉化的部分做得很好，我觉得就是不管是在地球地表啊，或者是甚至是深部地函，就如果你想要讨论tomography 的话，就是 GPlates 也办得到。那也因为它的视觉化效果很好，所以大家在研究上跟在教学上都有很多的使用。像是研究上的好处就是，当你在讨论一些几百万年前发生的事情的时候，因为古地理已经完全不一样了。那这个时候如果可以有一个古地图，把你的想要呈现的资讯放在上面的话，这样子，对于研究上的沟通啊等等的都是有很大的帮助的。然后这个优势呢，也延续到就是教学的部分。就我知道 GPlates 的社群啊，其实有很大一部分是高中的地科老师，因为他们会使用 GPlates 来给学生看说，哦，那个板块运动就是这样子进行的，这样就很方便。不管你是要一个某一个时间点的 snapshot 的样子，古地理的样子，又或者是你要一个影片，就是从几个百万年到现在的那个古地理演变也都可以。And the other thing good about GPlates that it's a cross-platform software. Like you can use it on Windows or Macs or Linux with easy installation. And the part that I really appreciate is that it's an open source software with the community framework. Like it's like GPlates itself. It's a software that you can like enable those plate reconstruction models, and Earthbite groups does release all kinds of reconstruction model by themselves from time to time. Like they're kind of pushing the time further back from like 400 million years to 600 million years. And right now they just released the 1 billion years plate reconstruction model by themselves. But on the other hand, the GPlates is also be able to allow people who want to build their own reconstruction models, right? Like if you're not happy with their models, then you can just build your own on this platform. 就是另外 GPlates 的优势呢，就是它首先在很多的那个作业系统上都可以使用，Windows、Mac 或者是 Linux 都可以。此外呢，因为它是一个开源软体，所谓更仔细的来说是说，它是由 Earthbite Group 来开发的嘛。那 Earthbite Group 呢，它每 每过一段时间都会释出那个新的他们自己的板块重建模式，就是从前几年从400个百万年一直推到600个百万年，然后去年最新的版本是过去1亿年的板块重建，那个是 Earthbyte Group 他们自己所推出的 reconstruction 的那个板块重建模型。但是虽然他们有自己的模型，但是 GPlates 这个 platform 呢，就是这个软体呢，也可以让任何使用者来去开发他们自己想要的板块重建模型。就是如果你对他们的重建模型不满意，那你可以做你自己的这样。其实也是蛮常发生的，因为毕竟你在做那种全球的板块模型的时候，你势必要在每个地方都做出选择，就是一定会，就比方说台湾好了，就已经有很多的想法在大家呃在互相 debate 了，在互相就是 well 就是有很多想法啦。那你因为你需要一个全球的板块重建软体的板块重建模型，所以你势必在每个地方都要做出选择。那这是不可能让所有人都满意的，对，所以你可以用 GPlates 来做自己的模型这样子。And the other thing that I really appreciated from the Earthbyte group is that they have maintained a really good well, like they have this all kinds of good materials for people who want to do self-learning, like they want to learn GPlates by themselves or PyGPlates by themselves. And by the way, like I believe like or say I'm sure I will not be able to cover everything in GPlates at the like this workshop. So that's fine because with all these materials, you can just check whatever you want to learn from these resources. 就是另外一件事情是 GPlates 啊，它有开发了很多的那个学习资源啦。就是如果你想要自己去学 GPlates 的话，这边有很多的资源在这里。And I'm going to show like some of it. Well, where's my cursor? Okay. So, like for example, they have this GPlates tutorials, and can you see the website right now, or just the slides? 你们现在有看到网页吗？
没有。
没有看到网页。好，那我应该是要那个。On just the entire screen, share, and okay, so this is GPlates tutorials. Like, it has the tutorial for every steps, like every, or say most part of the GPlates function. Like, and you can just click in, and then each of the chapter, they have like the files that you need in this tutorial chapter. So like you can load. Well, where's the files? Oh yeah, like these are the inclusive files that you will need in this tutorial chapter. Then you can just download it and then follow the steps to learn how to do, for example, for this one is loading and saving the data. And on the other hand, you also have the GPlates user manual that is talking about every details in GPlates. Like, yeah, it's basically a user manual, like showing everything that you might want to check. And also, they got this GPlates forum. It's a forum that you can ask questions, and then they like the Earthbyte groups actually had hired a bunch of people to answer all the questions on here. Say like yeah, you can just register a account and then ask question, and people like there will be people who ask who answer your question. Yeah. 好，首先就是，我我确信我应该是没有办法在这2天内把所有的 GPlates 的东西都讲完，所以但是这也没有关系，因为GPlates 就是或者说 Earthbyte Group 他们有提供了很多的学习资源，就是包含了这个 GPlates tutorial， 就是GPlates 的教程，然后它里面有的东西呢，就是真的是一步一步的教你怎么做。这样，比方说这里的第一节就是从载入还有存取你的那个资料开始。那每个章节呢，它都会有就是这个 include file， 就只说在这个学习章节里面呢，你需要这一些那个档案，这样，那可以就先按这边，然后 download 就是下载这些档案之后呢，再依照底下的那个一步一步的步骤，然后你就可以学到就是这一章所要讲的东西，这样。然后再来呢是那个 GPlates User Manual， 就是有在这吧？没有吗？没有 ，OK。User Manual 就是使用者的我不知道叫什么，就是有很多就各种的细节都在里面啦。对，那再来呢，就是如果说你在使用上有任何问题，然后你可能也就是好像查不太到要怎么要怎么做，那有另外一个地方是 GPlates Forum，这边就是一个论坛啦，一个 GPlates 的论坛，那它也是由 Earthbyte Group 的人来去维护的，就是是付钱请他们维护的。你在上面就是你 login 你就注册之后，或者是 sign up 注册之后呢，然后你就可以开始问问题，然后会有专人来解答这样子。对，大概是这样。然后你也可以去看看，就是别人做了什么，然后他们的回答是如何这样子。And also there's this Earthbyte resources. Like this page includes lots of files that you can use in the GPlates reconstruction. Like you got all the data like global and regional plate motion models. Like there are all kinds of models here. You can find like the recent model released by Earthbyte Group, like this 1 billion years model, and then there are also models that they were released in the past. And there are other features that you can dig into as well, like say that this is seafloor magnetics files, like you can just download it and then use it on GPlates. It's quite easy for just like go through everything and then find out the things that you want. 另外一件事情就是GPlates 呢，它还有一个那个Earthbyte resources， 就是任何跟板块运动相关的资源，就是这个应该说跟他们有关的资源啦，它也都会放在这个地方，就是Earthbyte resources 里面。那这里面有的东西就是各式各样的档案，比方说我刚好提到说，有很多种不同的那个板块重建模型嘛。那这边放了比较是跟 Earthbyte 他们自己相关的，像最近那个发表的就是这个11年以来的 reconstruction model， 就是你也可以按进去，然后下载之后那个档案就可以直接在 GPlates 上使用。然后此外还有其他比较就是之前释出的模型啦，这样子就你都可以在这边找。然后此外呢，除了 reconstruction model， 除了重建的模型之外，还有很多其他的东西你可以使用，像是这个 seafloor edge 啊，它就是那个应该是用 第10条带所画出的板块全球板块年龄的分布图，这样就是你也可以去 download 档案之后呢，直接在 GPlates 上使用。就是它很多东西你可以就是自己去发掘啦，真的蛮好的，So right, okay. So anyway, like I said, I won't be able to cover everything today and tomorrow, but you can just dig in all that resources there to learn more about GPlates or find those data that you might be interested. Now let's start talking about the ideas of plate construction back in time. Like we know the plate tectonics at present day looks like this, right? I wonder if there's a laser pointer or something. Laser pointer, great. Right. So we do have this kind of present day plate plate tectonic map. Like we know, like the present day plate tectonics looks like this. But how are we be able to go back in time and constrain how each of these plates moved through time? Like say back in 150 million years ago, or 300 million years ago, or even or even more. 就是我们知道现在的板块地图长得是这样子，就是有太平洋板块，然后有欧亚大陆板块等等的。但是我们要怎么知道说这些板块在过去怎么移动，然后要用什么样的方法来去制约就是这个板块模型呢？就比方说我们要把它时间往后推到150个百万年或者300个百万年以前，这样子，就是它们板块的位置一定都不一样了嘛。就我们要怎么去制约它之前的位置呢？Yeah, so how are you going to constrain all this? So actually, there's some materials that we can use from the seafloor fabrics. And this is one of them, like the fracture zones along the oceanic floor. Like these fracture zones are kind of the extension of those transform faults between mid-ocean ridge. Like if you zoom in into the Atlantic Ocean, and then you can see like this is the mid-ocean, like Atlantic mid-ocean ridge, and the mid-ocean ridge has kind of this transform fault between ridges and ridges, right? And then the fracture zone is kind of the extension from the transform fault. And from that, you can kind of know what plates were moving by the time. And most in this case, that's like when the middle Atlantic Ocean opened, it separates the North and South America from Africa and Europe. And then you can show like how the relative motion between these two blocks were doing through time, like from these fraction zones. 就是当我们要在制约一个板块模型的时候，他们使用了很多海洋地壳上面的一些东西，其中一个呢就是 fracture zones， 抱歉我不知道怎么翻中文，就是 fraction zone 呢是指说 mid-ocean ridge 之间啊，它都有这样子的那个转型断层，就是中洋脊之间都有一些转型断层。就比方说这边是大西洋的中洋脊，然后你看到就是你如果放大来看的话，它可能会长得像这样子。然后这是 mid-ocean ridge， 这个是中洋脊，那它们之间呢都会有一些转型断层。那这些 fracture zones 就是转型断层的延伸这样子。然后透过这些延伸的形态，你可以知道说，他们过去张裂的轨迹是怎么样的。那以大西洋的张裂当例子来说的话，就是大西洋中央脊张裂的时候呢，它就把北美跟南美板块跟 那个非洲还有欧洲分开了嘛。那你透过这个 fracture zones 它的形态，你就可以大概知道说，过去的这大概是200个百万年吧，他们两边的那个相对移动大概是如何。And then another thing that are frequently used in plate reconstruction models is the magnetic anomaly. Magnetic anomaly on the ocean floor. It's like you know the parallel or say the magnetic pole, like North Pole and South Pole of the Earth will switching between each other from time to time, right? And like while all these mid-ocean ridges were creating the new oceanic crust, like while also recording all this magnetic switching events. And that's one way that we can understand how like the age of each part of the mid-ocean ridge. I mean, each part of the oceanic floor. So one of the things that Earthflight group had did is like they picked out all this magnetic anomaly and then like globalized magnetic anomaly and then make this kind of the seafloor ages map from that. So you can see here like the red means the oceanic crust that have been generated like recently from the mid-ocean ridges, while further back in time it's like blue and purple are those older ocean floor, right? And like that can also show how the mid-ocean ridge was, or say how like the plates was between the two sides of the mid-ocean ridge was moving apart from each other from time to time, like with age constraint. 就另外一个可以拿来当做制约的东西呢，是海洋的地磁磁条带。那它的原理我应该是不用多说了，就是那个地磁南北极会随着时间不断的变换嘛。那它在变换的过程当中，这些重量级也在一边张裂，形成新的海洋地壳。那这些新的海洋地壳呢，就是玄武岩啦，他们也会记录了当时他们形成的时候的那个古地磁的讯息这样子。所以Earthflight Group 他们做的其中一件事情呢，就是去把这一些海洋磁条带的东西给挑出来，然后把它变成这样子的一个全球海洋板块的年龄的那个模型这样。Oh, it's already 6 o'clock. Wow. Okay. Right. So from the fracture zones and the magnetic anomaly, we can understand how plates were moving relatively to each other. So, and you can actually even have this plate circuits. It's like, you know, the relative motion between plate, like North America and Eurasia. And also you can understand how Eurasia and India were moving relative to each other. And also how India were moving relative to Africa and then back to North America. Like it's kind of a plate circus that is a self-consistent model that's showing how the plates were moving from each other, like, right? And it can actually be a quite good constraint, like showing how the plates are moving relatively to each other. But the thing is, the relative motion does not show how the plates, the location, the exact location of each of the plates. Like we know they are moving relative to each other in this way, but you can actually move the whole relative plate motion system like 90 degrees, while with all the continents are in the different location comparing to the previous scenario, but this scenario all have the same relative plate motion, right? 就是我刚刚是在说，前面那些东西呢，你可以 知道说板块之间是怎么样子相对运动的，但是相对运动并不能够让你了解说那些板块它各自实际上的位置在哪里，就是在地球历史上的实际位置上在哪里。因为就是比如说我知道我可以把这整个相对运动的那个系统，就是移动个可能90度吧，90度往南。那么这些所有的板块都会在就跟前一个那个样子比起来，也都在不同的位置。但是这两个状况之下，他们彼此之间的相对运动也都是一样的。And that's why we kind of need an absolute reference frame to fix this whole thing, right? And more specific speaking, we have to have this absolute reference frame that correlates to the surface plates to the deep mantle, like assuming there's a part of the mantle that is remain like it's not moving for the whole time, then you will be able to fix all this relative plane motion system to the absolute location on Earth through the Earth history. 那就是因为我刚刚讲到说，那个相对板块运动跟它实际过去的古地理位置是不一样的嘛，所以这个时候就要导入另外一个概念，就是那个我还是不知道怎么翻 absolute reference frame， 就是算是说有点像是形成一个坐标系，让你可以把这所有的板块来知道说它在这个坐标系的哪一个位置，然后这坐标系呢，可能就是相对于或者说大家在使用上都是相对于地函深部某一个假设它不动的位置这样子。那如此一来，你就可以去知道说这些板块过去呢在地球上实际的位置在哪里。Any question？ 有任何问题吗？你可以直接就是打开麦克风打断我。Okay, so now one way people to achieve that is from hotspot tracks. So the hotspot tracks idea is like it's about mantle plume activity. Like for those deep-rooted mantle plume, like from the deep mantle, or say from core mantle boundary, people kind of assume, or say some people kind of assume that it was relatively, not moving through Earth history. Say, for example, the most famous one is the Hawaiian Pearl Trend here in the middle of north mid of the Pacific. And what happens, like there's this Hawaii hotspot, and some people like assume that it was just here all the time while the Pacific plate was moving and then changing the when there's when the motion was kind of changed, and they will form this kink here. It's kind of like you got a candle sitting there while you're moving a paper above it, and then there will be a kind of a burning track on the paper. So if we can assume, or some people kind of assume that this deep-rooted plume was just not moving through time, then it will become a good reference frame for having the absolute reference frame. 就是其中一个那个方式呢，就是使用那个 hotspot reference frame， 就是那个 hotspot 是热点，那热点的产生呢，就是跟一些那个那叫什么地函热柱的活动有关。那最有名的一个例子就是这个夏威夷帝王岛链，在太平洋的正中间的偏北啦。这个那 hotspot track 可以使用的方式就是说，有些人会觉得那个 mental plume 呢，它是一直在这里不动，就是它相对于那个 core mental boundary 来说，它就一直不动。那同时呢，这些板块呢是随着时间在活动嘛。那当板块就是通过这个 hotspot 的时候，它就会开始有一系列的火层作用，然后就形成了这个岛链。然后这个 kink 呢，就是这个转弯的地方，就可能是当时的太平洋海板块有某一些怎么说，就是它的移动的方向变了，就会显成这样，就是大概是这样。那当然我其实没有很想要就是去深究这些，因为有一个很热门的问题就是到底地寒热柱会不会一直就这样子不动？有些人说会，有些人说不会。那在做这些 hotspot reference frame 的时候啊，大部分的或者说我看到有一些 model 他们的做法是说，因为 relative plane motion 就是刚刚讲的那个 plate circuits 那个板块运动的相对运动，它也是一个制约，然后他们就是把那个制约再加上这个 track 的行为，就是透过一系列运算之后呢，来算出这个 hotspot reference frame。然后其实有些人的那个 hotspot reference frame 只是认为说夏威夷岛链的这个夏威夷的 mental plume 是有一点点移动的，所以就是它是一个使用的方法啦。Yeah. So I was talking about like there's a great debate between whether the mantle plume was moving throughout Earth history, like whether it's like just fixed there with the core mantle boundary or it's like kind of moved through time. Now I don't really want to dig into those debates, but when people using the hotspot or say they're building this hotspot reference frame. One way they use is like they had the plate circuit and this hotspot track, and then calculated in a way that like it's like everything is self-consistent. And in some of that those reference frame, that actually shows that the Hawaii plume has a little bit movement through time. Yeah, and so, but when talking about those ocean seafloor fabrics on oceanic plates, which is quite useful, but the downside is that oceanic plates are keep consuming, like subducting along those active margins through time, right? And can anyone tell me like what's the oldest oceanic plates on Earth at present day? Like 有人知道那个海洋板就最老地球上目前现存最老的海洋板块是多老吗？ Like how old? Yeah.
200万。
Yeah, 200 million years old, right? So the thing is, you can only use this fabrics, seafloor fabrics, when they exist, right? But actually, the reality is that you don't have to wait until 200 million years ago. Like even, say, like let's trace the time back to 50 million years ago. I bet it's like half of the existing oceanic crust are gone. So it's like we lost half of the oceanic fabrics there. 就是我们在使用那些那个海洋地球上面的这些地质constraint 的时候啊，有一个很麻烦的事情就是 因为海洋板块是随着时间，它会一直不断的隐没到海洋地壳大陆地壳底下嘛，就是沿着那些活动大陆边缘隐没到那个地海里面。那换句话说，我们的这一些地质记录是不断的流失的，所以就算说最老的海洋地壳是200个百万年好了，其实不用等到200个百万年前，只要到50百万年前。我们就已经损失了一半以上的海洋地壳的记录，所以，这些东西啊，到了大概50或80个百万年之前，其实就已经没有办法也就是说已经没有什么材料可以供我们使用了。Yeah, so like since all these oceanic fabrics are gone into the mantle, and then like back to 50 or 80 million years ago, there's not much material we can use from the seafloor fabrics. And that's the time, or say like before that time, before 80 or 100 million years ago ish, most of the reference frame will, well, all of the reference frame will almost entirely relies on paleomagnetic materials. It's like using old like global-wise database of paleomag, and then calculate the true polar wonder through time, and then understand how like the sampled area was in there in specific coordinates back in Earth history, which is you know, of course we can also use the paleomag reference frame whole time, like just get rid of the seafloor fabrics constraint, like get rid of the hotspot reference, and actually there are pure magnetic reference frame out there, right? But the thing is, like, you know, paleomag is sometimes can be like there are uncertainties, especially when you're talking about a global wide record. Like, it's not just about the longitude and latitude back in time, but also the age constraint is another thing that you have to think about. So, yeah, that's about the paleomagnetic reference frame. 就说因为在80或100个百万年以前的地球历史啊，那些海洋地壳上面的 constraint 就已经都没有东西可以用了嘛，所以大部分的 reference frame 呢就会就是开始几乎全面的使用古地词来作为那个reference frame 的材料这样子。那但是古地词也是有一些uncertainty 的，像是这就不只是说古纬度或者是经度的问题而已，而是在年代的 constraint 上面也是就是也是需要考量到它的uncertainty 嘛。所以虽然说确实有一些 reference frame 是纯古地词的 reference， 就是它根本就不使用那些hotspot reference frame 的东西，就全部都是古地词。但是目前GPlates 的或者说 Earthbike 他们释出的 plate reconstruction model 都是以至少在80个百万年以来是 mental reference frame 有被考虑到的这样子啊。And so yeah, so there are hotspot reference frame and then paleomagnetic reference frame, but most of the case is like it's kind of hybrid because, well, you know, like some of them are kind of using hotspot reference frame in the past 80 million years, and then before that they're turned into a paleomagnetic reference frame. I will just one example, which is from the Torsvik, well, Torsvik 2019 paper. Like, it's a reference frame developed by the seed group in North Europe. I'm really sorry about that. I forgot the like which country they're from. But anyway, like, this is their kind of hybrid reference frame. Like, they have the hotspot reference frame after 80-ish billion years, and then before that they have the paleomagnetic reference frame for their plate reconstruction. And it's like what they're describing here is kind of the plate circuit I was talking about, like the way they describe how they were moving, the relative motion to each other is like they describe how Antarctica was moving relatively to South Africa, and then Australia was attached to West Australia was attached to East Australia, and then West Antarctica was attached to Pacific, and something like that. And well, most of the reference frame that I saw, they use South Africa as the one that attached the whole plate circuit, or some people call it the reconstruction tree, like that attach the whole tree into the mantle reference, or is it the absolute reference frame? Because South Africa is, I would say, the most stable craton or continents through at least the past couple hundred, like, or they through the whole Phanerozoic. So like when they kind of compare the locality of Africa between different reference frame, they're all kind of sit in the similar locality, and that's why they use the South Africa to attach all the plates they can get in the plate circuits to the absolute reference frame. 就是比较常见的例子就是这种那个混合的 reference frame， 意思是说像以这个 Torsvik 的 reference frame 来为例的话呢，它在80个百万年以后呢是使用 hotspot reference frame 的，但是因为在它之前呢，就是我们就会变成是 paleomag， 就是古地磁的那个 reference frame。然后这边中间在讲的事情是说，我们刚刚有提到说，我们可以用那些 seafloor fabrics 来描述板块之间的相对那个移动嘛，那就会形成一个 plate circuit， 然后也有人说是 reconstruction tree， 就是reconstruction tree， 就以这个例子就是说，它呢就是描述那个南侧的南极洲对非洲板块的相对移动，然后那个南极洲的西侧跟澳洲呢，又有一些 constraint 是知道他们跟东半部的南极洲是怎么互相运动的。那此外呢，就是西侧的南极洲又跟那个太平洋板块连在一起，所以这样子就是会是有一个整个板块相对运动的 reconstruction tree 这样。那大部分的 reference frame 都使用非洲来当做就是把整串跟absolute reference frame 来连接的那个地块啦。那有一个很重要的原因，就是因为非洲它在过去的大部分的时间，就是显生宙以来，它其实位置都没有什么移动，就移动不多啦。那这边呢，它就稍微比较了一下不同的 reference frame 下这个非洲的位置，可以看到它其实没有什么太多的差别这样子。所以 这个大概就是 reference frame 的概念，这样。好，那等下这边要讲什么？Oh yeah, I was trying to use this this figure to talk about the idea of reconstruction tree, like oh right, okay. So the way they describe how the plates were moving relative to each other is from the rotation pole. Okay, so like in this figure here, we got 3 plates on this planet: plate A, plate B, and plate C. And then for the relative motion between plate A and plate B, it's kind of described by this rotation pole between A and B. And it's like, if we fix the plate A, then the plate B will rotate, have this rotate motion from this AB rotation pole. And then we also got this BC rotation pole that describes the relative motion between plate B and C. It's like when B is fixed, then C will rotate from this rotation pole here. And then we also have the rotation pole between A and C. It's kind of like the plate circuit that I was talking about, right? Like it's come back to the motion between plate A and C. And that's how they describe the relative motion in the digital, in any of the, well, in the digital plate reconstruction models that adopted into GPlates. Okay. 对，我这边要讲的是说，在那个板块重建的模型里面呢，就 GPlates 使用的板块重建的模型里面，他们描述这些不同板块的相互运动方式呢，是这样子的，就是首先这个星球上就只有3个板块好了，板块 A、B 跟 C。那板块 B 呢，相对于板块 A 的那个移动，就是透过这个 rotation pole。就是叫什么旋转轴来表示，就是如果你把板块 A 给固定住，那板块 B 呢，它在它的旋转的或者它移动行为呢，就是由这个 AB 的旋转轴来运动这样子，然后 B 跟 C 之间又是由这个BC rotation pole 来表示，然后C 跟 A 之间呢又是由这个 AC pole 来表示这样。那就又连回play A 这样子。那我会讲这个是因为在 GPlates 里面呢，有2个很重要的档案是来描述整个那个板块的重建的档案啦。然后其中有一个档案呢，就是在讲这件事情。那待会我会在细部去讲。And so the other thing that will happen when all the seafloor fabrics are no longer exist back in time is that you also have to reconstruct plate, oceanic plate as well, right? Because it's all gone. And people in this case, like people will have to use other things like for those oceanic plate that is still in the mantle, people will use seismic tomography to identify them. Or another way is it's like look into the geology along those active margin to look into those geological records for subductions and then understand how the subducting place looks like back in time. Like I'm talking about like those consequences from subduction, like the magnetic arc or accretionary belt along the plate boundaries, something like that. 那另外一件比较麻烦的事情，就是如果你在地球历史里面是那些已经没有海洋地壳可以的资讯可以使用的那些时间呢，还有另外一件麻烦的事情，就是你连海洋地壳也都要重建。那这个时候呢， 大家会使用的一些手段，就是包含了说，比方说这些板块它可能还在地函里面，那我们就可以透过 seismic tomography，我不知道怎么翻中文，就是它是侦测成像吧，应该这样说。就有点像是帮地球照 CT 的那种感觉，然后来去辨认出那些板块。然后此外呢，在那个活动大陆边缘呢，也会有一些过去的隐没历史的证据，这样，比方说那些岩浆作用啊，就隐没带相关的岩浆作用啊，或者是古增肌岩体的记录啊，都可以告诉我们说过去的那个至少这个隐没带的隐没历史是长怎样，然后就可以去回推那个过去正在隐没的板块是长怎样这样子。All right, so that's pretty much all I've got for like introducing the ideas of plate reconstruction. And um, I wonder if we like take some like 5 minutes break before we get into like later using the G plates. Do you want a 5 minute break? 就我已经把大部分的就是我想要讲的那个关于板块重建的概念都讲完了。那下一步但就是开始实际使用 G plates 啊。那我在想说，我们要不要休息个5分钟再回来？
好，休息。
呀，好，那就
45分回来好了，我们这边45分。
好好好 ，OK。那我先关掉。所以你要有什么问题，也可以现在跟我讲一下。
没关系，等真正教之后，后续很多细节再问。不错，先让他们有一个基本的概念，不会一下
对，
直接
因为
不会直接进入，
我
一下子直接进入操作阶段。
因为我会讲那其实也是因为就因为我知道老师其实有点想，就是有一个想法是想要呃就是优化目前的板块重建模型嘛我觉得这样你就可能要开始去修改那就是我刚刚讲的那两个 file。那如果可以知道就那两个 file 到底怎么运作的话，会比较好上手这样。
对，没错没错。所以这是你第一次上课吗？
请教一下，除了 GPlate 之外，刚刚有提到还有其他的那个软体吗？
有，但是坦白说，我都没有使用过。有一个叫啊、抱歉，我得去查一下。对，但我会说 GPlates 是目前最成熟的，因为我刚好提到它有很完整的那些学习资源嘛，然后甚至还有论坛。嗯，我这些好像都是我没有看到其他呃，或者说其他的板块重建的那个研究团队有发展出这么成熟的那个体系，这样子。
谢谢。
嗯，
再请教一下，那
嗯，
个 EarthByte 跟那个您谈的那个澳洲 Earth Science Group，他们是同一个组织吗？
没有，就只有25 groups 了，就是Earth Science 就是没有，就是25 group，就是25 group 是主要是以雪梨大学为主的一个团队，这样。我知道里面的人都是在雪梨大学，对。那因为澳洲政府应该就是他们澳洲的政府对他们蛮支持的啦。我刚刚忘记提说，嗯，他们澳洲有一个叫做 OSCOPE 的 OSCOPE 的那个组织，就主要是在推广澳洲的那些开源的软体啊，或者是开源的资源使用的。那呃，就他们有很大一部分的那个，就25 Group 有很大部分的资源的资助是来自那个 OSCOPE 啦，就他们政府蛮支持的。嗯
谢谢。
嗯，
再问一下，您先前给我们的那个有一个压缩档，那个主要是会在今天还是明天会介绍？
今天就会使用了，今天就会
哦，
使用了。
好，谢谢。
嗯，
好，钟伟可以开始啊。
好，OK。Um, right. Before we start using the G plates, is anyone having problem install G plates on your computer or laptop? 就是因为我们待会会开始使用 G plates，那你们有人对就是安装上有什么问题吗？如果没有的话，我们就开始喽。OK，好，那let's see。看一下我的小抄。Right. So first thing, of course, is open the G. Right. I'm going to share my screen. Um. So yeah, I will start demonstrate the G plates on some of the basic function, and you're welcome to uh like like following me with like doing all this stuff. And also, if you have any problem, like just interrupt me, and I will just show the procedure again. Okay. Um, entire screen. Right. I think this is Okay. Right. So first thing, of course, is to open the GPlates, right? Just click it and then open it. And then why it's in here? 现在就是把 GPlates 的那个界面打开嘛 right? So this is the GPlates interface, and you might want to kind of expand it, like adjust the size of the interface so you can look everything clearly. And like, so yeah, this is GPlates interface. Like it got a menu bar on the right side, left side, and also another menu bar on the top. And I believe for Windows user, the top menu bar will be directly above the interface, right? So 对 GPlates 的打开之后呢，界面就是长这样，然后上面就是有 GPlates 的那些功能，然后在这个视窗的右边呢，也有一系列的功能列表这样子。And this is the sphere that we are going to work on for plate reconstruction. 然后来。Now, first thing we will go through is loading files. 然后第一件事情呢，就是那个载入档案。And there are two ways to do this. One is to click on the file of the menu bar above, and then move to the open feature collection, like the first one. 好，那个要载入档案的话呢，第一个方法就是它有两个方法，第一个方法就是打开那个 file 档案，然后选择第一个 open feature collection。对，应该就是英文吧，应该不会有中文的。Yeah, open feature collection and click it. And what's happening? Okay, and then you will be able to choose the file, and please just go to the file that I asked, like the zip file that I ask you to download. 那就是我们要打开档案就在我之前请你们下载的那个压缩档里面。Right, for me. Right, so the file folder will be something like this, like got polygon file, rotation file, and then other stuff. 就那个我请你们下载的档案是长这样嘛。那第一个档案 well, the first file I would like to ask you to open is like the topography file. Just click it and then open. 那我们就打开第一个档案是那个 topography， 就是全球地形图，然后就选取它，然后再按 open 打开这样，然后它就会在那个你的界面上面了。And then you can see like the topography file is on the interface right now. And there's another faster way. 然后这是一个方法啦，然后还有另外一个方法是比较快的，就是I'm going to delete the layer first. Right. Yeah. So another way, which is faster, is just drag the file and then release on the top of the GPlates interface. 就另外一个比较快的方式呢，就是你只要把那个档案拉到 GPlates 的界面上，然后放开，这样就好了。Like this, like the topography file, like right this one, topography GPML, and then just drag it and then release it, and you'll be here. So it's actually my favorite choice. Like it's just way more straightforward. And what's next? Okay. Right. So next, I'm going to talk about how to controlling the view on the GPlates interface. First of all, it's like if you don't like or say if you want to move to other part of the Earth, you have to choose like this drag globe function here, and then just drag drag the Earth around. And if you want to zoom in and out, one way doing this is switch to the zoom in and out mode. Well, this actually is only zoom in mode, and then double click on the area that you want to zoom in. Say like I want to zoom into Taiwan, then it's like this. Well, just click once, and then we'll keep zooming. And then there's this bar here to the right that you can adjust the zoom in out。就是如果你要 zoom in 或者 zoom out 的话呢，你要先 switch， 就有一个方法是你是先 switch 到这个 zoom in 的这个模式，就刚刚是在这里嘛，在这边你可以就是拖着地球到处乱晃。那但是你这时候你就要切换到这里，然后就是点一下，它就会开始 zoom in 到你想要去的地方。然后如果你想要再缩小的话，那就是右边这边有一个那个地方可以让你缩小放大。And this is one way. And another much more straightforward way is like go back to the drag mode and then just scrolling your mouse wheel, like scrolling your mouse wheel back and forth, then you can just zoom in and out. Okay, and while you can also like drag the Earth anytime. And this is also kind of my favorite option, right? 就另外一个方式呢，就是你也不用到这个 zoom in 的选项，就还是回到原来那个 dragging mode， 然后就使用你的滑鼠滚轮，你的滑鼠滚轮就是滚来滚去就可以让它 zoom in 跟 out 了这样，然后同时你又还可以就是这样 drag 这样，我是觉得这样比较好用啦。Right, and what's else? Okay, then another thing we can do is change the projection view. So right now it's the 3D orthographic view, but there are other coordinate systems that you can use, like rectangular, which will become this, or Robinson, which will become this, something like that. 然后另外可以介绍的功能就是这个切换你叫什么？切换投影坐标系统的选择，就是一开始呢是这个模式啦，然后但你在右下角的这个 view 这边呢，你可以切换到麦卡托或者是 Robinson 等等的。So yeah, you can either switch between the coordinate system from the like this view at the left bottom corner, or the other way to switch it is click on this view on the menu bar. 就另外一个切换投影坐标系统方式呢，是到 view 这边 ，and then find set projection, right? 然后就是第一个是 set for projection， 然后按下去 ，and then you got like this small windows, so you can have the projection switch between like all these 5 choices here. And another thing you can do here is that define the longitude that you want to put in the center. 另外一件就是这个小视窗可以做的事情是，除了你可以切换 projection， 就是投影系的坐标系统之外呢，你也可以去切换你想要放在中间的精度。And in this case, it put the latitude 0 degree at the center, right? It's like it's actually because it's showing the Pangea much better. So that's kind of the default system for most of the plate reconstruction model. But if you don't like it, then you may also say I want to do Robinson, and I want to put Pacific in the center, and so you can put one. Wait, what's happening? Okay, sorry, 180 here at the center meridian. 如果说你想要把那个投影的中间的那个经线从0度换到以太平洋为中心的话，你就可以改这边 Central Meridian， 把0改成就是180度经度 ，and then click OK， then it will switch to like this kind of view, like with Pacific in the center, right? So that function will be working in the 3D or orthographic system because like it's a globe. Well, it can work for like all other choices. 对，就是你现在就看到是那个以经度180度为中间，也就是那个太平洋为中间的样子的。那这个功能就是只对这个 3D orthographic 以外的那个投影坐标系统适用啦，因为 3D 那个它就是 3D 嘛，你可以转来转去，更没有什么中间经线在哪里的问题。Right, so this is about view, and alright, and let's take a look at other function in this view choices. Like so other thing we can do is like camera location is kind of like view, camera location, moving up, yeah, just moving up a little bit and then moving down, something like that. And you can also rotate clockwise or anti-clockwise, kind of like, I don't really think we need that, to be honest. And also we can do zoom in and out here. 就是在这个 view 的选单底下，你还可以做其他事情，像是用在这边来去调整那个你的视角，可以就是往上移动、往下移动，或者是旋转，或者是 zoom in out。但其实我是都没有用到啦，因为刚刚讲那些就已经很够了。And then the other thing we can do is this computer text overlay。然后另外可以做的事情呢是那个在上面标定你重建的时间 ，OK， so when you click on this configure like the configure text overlay under view, and enable text overlay 就来启动它之后呢，so what this is will do is like it will put the reconstruction time on the screen here, like nearby the globe. 所以就这个功能是指说它会把那个你目前重建的时间放在那个界面的某个角落，你可以调整它的位置啦。跟I'm not going to dig into this. Like you can adjust the location of this right. It's like here, okay. Like because right now we haven't really upload the reconstruction model yet, so there will be only like present day, like 0 MA that can be shown here. 对，就是这样子。And so one benefit for this function is that if you want to do some play reconstruction movie, or you want to like output some of the play reconstruction like scenario, then this will have the reconstruction time directly on whatever you want to, like if it's video or a PNG file, this reconstruction time will be here. And then you can also adjust like how much decimal you want to do. Like for example, you don't want any of decimal, then you can just put it 0. And then you can also adjust the location by here. 然后对，就是这个东西的好处是，你如果想要输出影片或者是那个板块重建在某个时间点的样子的时候啊，你只要有这个 text overlay， 它就可以显示说你输出的那个时间点，就是如果是影片的话，就会一直不停的跳这样子。 然后这边你也可以调整，就是你要比方说这里 decimal place to use 意思是说你想要多少的小数点，现在是2个嘛，就是2，但如果你不想要的话就是0。然后此外这里呢也可以调整它的位置这样子，刚刚这边是20嘛，然后20的话是长这样子，那我如果把它调成10的话，它应该是会靠中间近一点，没错吧？啊，不对，是更远哈。Anyway, yeah, that's the configure text overlay, and then I'll skip the velocity region, but I will come back later. And then this is the gratitude rules. Like, so what it does is like adjust the reference frame for longitude and latitude. 就是此外这边有个 configure gratitude 的意思是说，就是你可以调整你的那个经纬度的线想要隔多少的纬度显示。So like this is like longitude data and latitude data means that how much interval you want to do when you show the longitude and latitude lines. And right now it's like 30 and 30, which means that for the latitude, it's like we'll show 0 and then 30 and then 60 and then 90. Okay. 像这边目前是30的话呢，就是我们现在看到的，它那个有细细的白线，就是它是那个每隔30度会显示一个经度跟纬度的线这样子。然后 and the other thing you can adjust is the color. Let's say we don't want to make it more clearly. Let's just do black. And also I want to make it thicker. 就其他也可以调整是那个线的颜色，然后此外就是线的那个粗细，像现在2是比较粗嘛。And then right now we have changed some setting, and then now let's apply it. It's like click OK, and then you can see like this is the new longitude and latitude line you have here. Okay. What else? Okay, and now then there's the background color. So the default setting is like the background color is black. 然后再来还有一个是调整，就是这个后面的背景那个颜色。那预设的值是黑色的。那again back to view, and then there's this choose background color. 就是你要换那个背景颜色的话呢，就是也是在这边view 的下面有个 choose background color, and then just choose the color. Like they have different way to choose it. 对，你可以用任何一个方式来选择你要的 background. 那let's do a white background. Okay, just choose white or there's no color. Okay, whatever. And then click OK. 那我们现在选一个白色，然后click OK 之后，为什么没变白？为什么没有变白？How about yellow? Still not? Wait, what? Okay, I don't. What is it? Oh, is someone asking question or? Let me check the. Oh, it's just okay. But anyway, I don't know what's happening right now, but let's just skip the background color. Why is that? And the other kind of fancy function is that you can also show stars. Okay, like you can see stars behind the Earth. Right, so that's everything about. 就是另外一个功能是你也可以选择，就是你要不要有星空这样子啦。然后也是一样，在 view 下面有个 show star， 跟就勾起来就是 show 啦。然后and then let's jump into okay, much well, yeah. So now let's introduce the two files that define a plate reconstruction model. Okay. 我们现在开始介绍，就是任何一个 GPlates 使用的板块重建模型，它一定要用到的两个档案。So one is the polygon file, the other is the rotation file, and 就是有两个 file 嘛 ，polygon file and the rotation file. Now let's check the polygon file. So here I kind of have like two different versions of polygon file. Like one is this one, the other is the shape file. So GPlates can adopt some file formats, including the GPML file, which is kind of the GPlates made up file format. And also they can eat shapefile as well. Like shapefile is the format that you can also edit in any of the GIS software, like QGIS or ArcGIS. And that's actually the one of the most favorite thing I like about GPlates. I frequently modify those shape files in QGIS and then output them into shapefile and then upload to GPlates. So I say it's much easier. 就是关于现在我们开始使用 polygon file。那我这边放了两种 polygon file， 一个是 GPML， 一个是 shapefile。那 GPlates 它可以使用的档案类型有很多，就包含了这个 GPML 的档案类型，它是GPlates 自己开发的 format。那另外一个呢，就是 shapefile， 就是 .shp， 然后通常它还会要就是跟其他的档案一起执行啦。那shapefile 有个好处就是它适用于其他的 GIS software， 就是像 QGIS 或 ArcGIS， 你都可以在里面先编辑好 shapefile 之后呢，然后再把它放进 GPlates 里面来做其他事情。就我是蛮常这样子做的。Now let's take a look at the polygon file, right? I'll upload this one first, like static plate polygons 2019 shapefile. 那我先把这个第二个 shapefile 先给打开。Now, so what shapefile do is like cut the Earth crust into pieces. Okay, like I'm going to change the color so you can see it much clearly. Single color. I'll get to here later. Close. Okay, right. So what it do is like it cut the crust into pieces, and then it will and it will also assign plate ID to each of the plate. Say like right now I'm using another function here. Is like choosing the plate ID, the plates, and then look into its detailed information. Like I'm doing this and then click on this, and then so I can choose the plate that I want to look into. So 那个 polygon file 它在做的事情就是把地球的表面切割成不同的那个 plate 的地块。那每个地块呢，它也都会有自己的 plate ID， 就是它算是它的辨识的那个号码啦。那我现在在使用另外一个功能，就是我刚刚在 rotation mode， 然后现在把它 switch 到feature inspection， 就是在这里面你可以就是看这些各个不同块体它的资讯，然后也可以编辑它。那目前我只是就是选取就按这里，然后你就可以开始选任何一个地块。那比方说台湾好了 ，right？ 好 ，OK。So right now this is West Taiwan. Interesting. So here you can see like they have plate ID for each of the blocks here, and there are also other stuff here, say like the valid time, meaning that which time frame I want this block showing on the map. Because when you go back in time, it's like some of the blocks, say like they are accretion belts that has just formed at a specific geological time. And then so ideally in this reconstruction model, we have to make this belt shown up not until that time, right? Like if it's an accretion belt that formed around 200 million years ago, then you have to make like the value time from 200 to, or this is future, and some will say like 0, but future is like it will existed in the model all the way since 600 million years ago. 好，那个就是polygon file 它会给每一个地块一个 plate ID， 就是它的编号。然后呢，此外还有很多其他的资讯，然后包含呢就是它在这个模型里面出现的时间。像这个例子来说呢，就是它出现的时间是从600到 future 到未来，就是它从600开始呢会出现在这个 plate model 里面。我知道应该大部分做台湾的人应该都不太会同意这件事情。But anyway， 就是这是他 define block 的方式啦。And what else? Okay, so yeah, that's polygon file. And then so like I said, the polygon file is used to cut the Earth's surface into pieces. But the other thing you have to do when do plate reconstruction is that you have to make these blocks moving along, like moving through Earth history, right? 那就是这个 polygon file 它做的事情是，就是把那个地球的地壳切成一块一块的嘛。那在做板块活动的时候，板块运动重建的时候，你要做的更重要的一件事情就是你要去描述这些板块它们如何移动嘛。And that's the purpose of rotation file， 就是这个就是 rotation file 在做的事情。And like this is the rotation file I put into the folder, which are two models here. I will use this one first. 对，这边我也放了2个那个 rotation file. Oh, by the way, the rotation file will always have this file name called .rot. Okay, like when you see .rot, it's a rotation file. 就是那个 rotation file 它的档案名称就是这个 .rot 啦。只要是这个档案名，它就是 rotation file. And now let's upload this one here, the Torsvik one. Okay, so drag into it, and now you can see. Oh, by the way, so another thing about the file management is like when you upload the file, it will show up here in this layers panel, so you can kind of walk around with the files. Okay, and well, I'll probably introduce this later. But anyway, let's talk about the rotation file. 就是那个你在开启某些档案的时候，它都会在这个 layers 的管理界面出现啦。就是你可以在这边展开啊，或者是展开它之后呢，就是对它做出一些那个事情这样子。我会在之后再讲细部的那个东西。But so right now we actually got the Torsvik plate reconstruction models here, right? The most important files are like this one, the rotation file, like it has the reconstruction tree, and then also the reconstructed geometry that was defined by polygons file. And oh, so that's the background. I didn't. Okay, I'm gonna switch it back to. Okay, that's the background color. 就是好 background color 是在 define 那个 globe 下面的东西的。Anyway, let's bring the topography back. Okay, so so we were talking about like each of the polygons here have assigned a plate ID, right? And then what rotation file do is to define how each of the plates was moving through the Earth history. And the way it defined it is actually like the reconstruction tree that I was talking about. 就是我刚刚说那个 polygon file 是它会给每一个 polygon 有一个 plate ID 嘛。那个 rotation file 它做的事情呢，就是去描述说这每一个 plate ID 它要怎么动。Which you can kind of check the reconstruction tree of the rotation file you are using from here, like the reconstruction and then the view total reconstruction pulse. 就你在导入那个 rotation file 之后呢，你可以在 reconstruction， 然后下面这里的 view total reconstruction pulse 这边去看它那个 reconstruction tree 是怎么形成的，这样。It will be something like this. So, for example, plate ID 701 is the Africa. 就是这个 plate ID 701呢，它就是非洲。Let me see if I can get to the Africa polygon. Right, so here fully. Okay, so right now I'm choosing on the South Africa block. 就我现在选取了南非的这个路块，然后plate ID 就是70 right? The plate ID is 701. And then what the rotation file is doing here is like 701 is the top of the reconstruction tree. And then it was attached to other plates like 201, and then 201 is also attaching to other plates here. Or say like 709 is also part of Africa, and then it's attached to another large continent, which is 501, which I believe it's Europe, maybe. 就是 rotation file 在做的事情呢，就是我刚刚讲的那个用 reconstruction tree， 然后来表达就是整个play motion 的行为这样。那在这边做的事情就是说70，也就是南非的那个板那块，它是整个reconstruction tree 的起点，就是它连接到其他的板块，比方说201这个板块呢，它是 fixed to play， its fixed play ID is 701。which 就意思是说201它的那个行为呢是使用那个它跟701之间的 rotation pole 来描述的 ，OK， and then the like 201 may also attach to other plates like 951 something like that， 就是这个是整个 reconstruction tree 啦。这样子，如果你有兴趣就是 dig in 的话 ，OK。And what now? So anyone have like question about the rotation file? If not,
Hi Jimmy.
Yes.
I have a question. So still, I do not know how to make a white color, just single color for the global Earthbite polygon map.
Do you mean?
Yeah, I just now is my polygon color very colorful. So how to make it become a
Oh,
single color?
Okay.
Thanks.
I was going to talk about this later, but I think we can do it now. Yeah, about managing the color of polygons. So again, this is the polygon file, right?
Yeah.
就是我现在来讲一下那个怎么样子去编辑那个 polygon file 的色彩。Okay, so you can change the color by expanding the polygon file from the layer panel here, and then find this set draw style. Okay, 然后你如果要那个就是更改那个 polygon file 它的颜色的话呢，你就是找到这个 set draw style， 在 polygon file 的这个底下，你就把它打开，然后 set draw style， 然后 and then click on it, and then there are multiple ways that you can choose how to color code this polygon file. One way is through the single color, like either everything is white line or everything is blue line or everything is black line, except the one that I'm choosing right now, right? 就是首先一个方式是你可以用 single color， 也就是说不管无论如何所有的线 polygon 的线都是白色或是蓝色、黑色。And then the other way is to color code the polygons outline with their plate ID. Okay, like that's why you got the colorful plate reconstruction. We'll say the colorful polygon. Okay， 就另外一个方法呢，是你用那个他们的 plate ID 来去那个 color code， 就是来去选择他们的颜色，就是不同的 plate ID 会有不同的颜色这样。And yeah, so you can see like let's just check here. So like for each of the polygon with different outline, like different color, that means they have different plate ID. Now we can also check it, like again, like put the function to the feature inspection function here. 就我们也可以看一下，就是看像for example, like this one here is part of the Pacific plate, which has the plate ID, and like these are all different pieces of Pacific plate. So although they are different polygons, but they all share the same plate ID, right? 901. And also the same color here because you are color code the polygons with plate ID. 就像这个是 Pacific plate， 我去把它打开会比较好，不要打开好了，这样会比较好吗？OK， 就是这边都是Pacific plate 嘛，就是那个台湾在这里，然后日本在这里，所以这边是太平洋。那你可以看到，就是它把太平洋切成不同的小块，但是因为他们的 plate ID 都是901，所以他们的那个颜色也会是一样的，因为你做你的那个 draw style 就是用 plate ID， right? And there are also other ways to color code the files. For example, like you can color code it by feature of the age of the features, and it's particularly useful when you look into the oceanic plates, like with different ages, right? 另外一个 color code 方式呢是用 feature age， 就是它的年龄。那这个对海洋板块蛮有用的，因为海洋板块它有不同的年龄嘛，所以你可以透过 color code 来了解，就是视觉化它的年龄效果。And the other thing you can do is like if you want to have a filled polygon, like you don't want to just having lines here, but on a filled polygon, then you can do this. Well, I'm gonna upload another file so you can see it more clearly, which is also in the workshop file here, but it's the age grid, okay? Like the Seaton Nettle 2020 present day age grid here. Okay, this is much better. Right. So although it's kind of different, well, it's kind of different, but still, what we can do is like kind of back to the polygon file. 就我们还是先回到那个 polygon file 好了，然后wait, is that draw style word? Okay, fill polygon, and then you can see like this is the whole Pacific plate with the youngest oceanic plate around the East Pacific rise, which is mid-ocean ridge, and like so the plates around it will be younger than the West Pacific. Okay. 就是因为你现在是在使用那个 feature age 来着色嘛，那像这块啊，它是太平洋海板块，那你就可以看到比较年轻的那个中洋脊刚出来的玄武岩，对，刚出来的海洋板块，就是这边大概是 East Pacific Rise， 就是对，它是中洋那个太平洋的对太平洋的中洋脊，还有这附近的板块的年龄是比较年轻的，就是用红色表示，然后越往跟西太平洋比起来就是绿色这样子。But you can play around with it, and yeah, and it's kind of like this. So, but this is a different file format called the raster, and which I probably will talk about it later. But right now I'm just showing you that you can. Oh no. Yeah, like that's one way you can play around with the color palette of the files. Okay. Okay, color palette. And now, let's do some player construction. I'm going to back to not filling polygon, and then use the single color. 好，就是现在我们开始，真正来做就是板块重建这样。那我就把 draw style 放回 white and blue， 然后 white 好了，这样会比较好显示。Okay, now let's say after we got these two files here, the rotation file and the polygon file, then you can start having this reconstruction. Okay, like you can drag this time bar here to say like I want to go back to 98 million years ago, or you can simply type in the time you want and then click enter. 就你现在有这两个 file 之后，你就可以做 reconstruction 了，就是你可以拖移这边的那个 time bar， 然后你也可以直接就是去输入说你想要到50 MA 之前的状况是这样子。But I mean, anyone would like, I don't want to just having the polygon, but also reconstructing the Earth's surface, right? Say let's reconstruct the plate, the topography, global topography, like back to 0 MA, and then enable topography here. By the way, this is enable and disable. Okay, so at this moment, if you drag this timeline here, it won't reconstruct the topography file. 就是如果你现在这状况之下呢，你在 drag 的时候，你还是只有polygon file 在重建。那个后面的这些 raster file， 就是这个例子是那个全球地形图是没有被重建的。And that's because you didn't attach this topography file to the plate polygon. Okay. 那现在你要做的一件事情呢，就是你要把 topography file 去 attach 到那个 polygon 这样。And the way to do this is again expand the topography file, which is the raster file that you wanna reconstruct, and then find the reconstructed polygons. Okay. 那你想要让连 topography 一起重建，就是任何一个 raster file 都是这样。你想要连 raster file 一起重建的话呢，那你就是把这个 raster file 展开， 然后find the 看到这个 reconstructed polygons, click on it, 点选它 and then you will find like there's a like they will automatically find all the polygon files that you have there, which is this one, right? Click on it and it will be here. 就你按它之后呢，它就会在这了嘛，对不对？然后在这个时候呢，你就可以重建板块了。Okay, right. So, like after doing this, you're literally constructing this raster here, and you can even disable the polygon file. So this is only the topography file that is doing the reconstruction here. 大概是这样，就是就是你现在就是那个 topography file 也是在 reconstruction 的状况之下的。And now you might find out like after 20-ish, like 240-ish million years before, like the reconstruction is no longer valid. That's because like this file only allows reconstruction back to like 300 or 200-ish, yeah, 200-ish time. Like 就是你现在可以看到，我们现在选的这个 rotation file 啊，它其实只有板块重建到大概250-40左右为止，然后在之前就不动了。那so that's the point when we want to do another reconstruction file, which again we need both polygon file and rotation file, right? 然后所以现在我们就要导入另外一个就是Earthby 更近期发表的那个板块重建这个 okay, like this is the reconstruction file that we're going to do right now. It's back to 1 billion years ago. Okay, like again we want to choose one polygon file for this, and then another rotation file from this here. And now you can kind of see like there's a marker like nearby this two rotation file here. Like yellow means rotation file. We got the Torsvik one and the 1 billion years Murdic one. 就我们现在有两个 plate reconstruction file, rotation file 嘛，那你可以看到这个勾勾，它的意思是就是说你要选哪一个 rotation file。我们现在选的就是这个 1 billion years 的状况 ，OK。And then I also want to choose like this one, and then also for doing the plate the topography reconstruction based on the new rotation file, you also have to change it, right? Right now, it's the Earthby like 2019, like this one, and we have to disconnect it. 就我们现在要把那个 topography file 的连接的 reconstructed polygon file 从刚刚选择的这个换成这个 so we want to disconnect it and then reconnect it to this one, okay? Like this is the 1 billion years one. And right now, oh yeah, because this one only have this polygon file only have the landmass part. So you can see like all the oceanic part were gone because the polygon file doesn't have the oceanic domain here. And so right now you can just start making this reconstruction file back and forth. Okay. And another thing for plate reconstruction is that this is what they call the animation panel, which is constrained like whether you want to go to a specific time or you want to play the whole video. Say like, oh, it's super slow right now. But anyway, like when you played it, it will kind of like starting from the oldest reconstruction time until present day. It's just too slow. I'm going to like accelerate it. So you can also play around with the animation time and speed from the reconstruction and then reconstructed. Well, is that so? Oh no, configure animation. That's so? Yeah, okay. Right. 所以就是这个 panel 啊，是调整你的板块重建它的影片播放，还有那个时间等等的。那有一件事情你可以做的是直接点这个播放之后呢，它就会开始就是从你最早的板块重建时间，然后开始往前推。那此外你也可以调整其他的一些事情，比方说那个板块重建的整体时间或者是它的速率。So you wanna find reconstruction and then configure animation， 就是你就点进去这个 configure animation 这里。So at here you can adjust like which time you wanna the video start from. And in this case, because the rotation file can push all the way back to 1 billion years, so you can actually make it like 1,000 million years. And then this will be a movie that start from 1 billion years to present day. And the other thing is that you can determine, you can choose the how many million years you want to make in this from time to time you want to make in this video. Say if it's 1 million years, then it's going to play the reconstruction for each of 1 million years. But if you want to do select 5, then it will be like playing from 1,995 and 990, something like that. And the other thing you can adjust is the frames per second. It's kind of playing with the animation speed. Say like for this one is like 5 frames per second, which means that if you're still doing 1 million years per frame and you're having like 5 frames per second, it means that for each 1 second they will play 5 million years, right? But if you're making it to like 2 million per frame, then it will become like playing for 10 million years per second, like 5 frames, which is like having a frame for every 2 million years, okay, and which will make the whole video faster. 好，我在这边在做的事情就是 configure animation， 它在做的事情是调整那个重建的算影片的一些细节吧。比方说你想要设定它从什么时候开始重建，那就是 animation start from and to，and 然后因为我们现在使用的是一个1亿年的重建，所以你可以就是使用1000个百万年，或者是800个百万年之类的都可以。然后再来就是这里指的是说你想要让多少个百万年就显现一次重建这样子了。就比方说你如果是1的话，那它就会从1999、998这样子跑。然后如果你是5的话呢，它就会是1000，然后995、990、985这样跑。那在这边呢，其他的选项就是你也可以设定，在1秒以内它要跑多少的那个 frame， 就是板块重建的那个图形。像这边做的这边的设置是说我每1秒呢跑5张。那假设这边还是每100万年1张的话，那就代表说它在这1秒以内呢，它会从1000跑到995。但如果说你这边设置的是我们用2MA， 就2个百万年一个 frame 好了，那这边就会变成说就是它是那个比较快啦，就是会从1000跑到这样是多少？990这样就会比较快 ，right？ 然后 Yeah, that's yeah. 然后再来你就会看到，就是他看现在目前是两个百万年在切换这样。Yeah. So that's about the animation, and well, it's 11:40 in Taiwan time right now, right? So I suggest like just call it a day, and then I will keep the workshop like we'll keep talking about other part of GPlates next day. OK， 就是现在我们就今天的部分可能就先结束这样子好了。
好，钟磊，可以麻烦一件事情吗？ 你刚刚有录影对不对
？Yeah
好，把它上传上去吧，把它分享给我们吧。
上传。
对，就是把它让大家可以看一下，因为复习一下嘛，会比较不会很容易记得，就麻烦一下这个连结。
没问题，
感谢。对，那今天不知道其他没什么问题，我们明天还有很多问题可以问的。
Well, if you have question, you can also ask me right now. Like it's fine. 就因为可能我现在我们这边是7:45啦。就你们如果不想要太早去吃饭的话，也可以就是问问题都可以。我现在先把那个录影停掉好了。